Hi, my name is Teacher Abby, and in this video, we're going to be going over question number 15 on section 5 of the GRE General Practice Test number 3. This one is a multiple select answer, so you can choose as many answers as you think are correct. So we want to know which of the following inequalities has at least one positive and at least one negative solution. So we want to basically find the answers to each inequality and see, do we get at least something positive and something negative in each of them? So let's start with A. 5/3 x is less than x. Well, to solve that inequality, I'm going to start by subtracting x from both sides. When I subtract 1x from 5/3 x, I'm going to get 2/3 x, and that's less than 0. Now, I could divide by 2/3 or multiply by 3/2 on both sides, and that's going to give me x is less than 0. If I think about that on a number line, 0 is right here, and it's not included, and I'm going to be less than it. So it's going to be all the values to the left. Well, those are only negative, and I want at least one positive and one negative solution. Well, I didn't have any positive solutions, so we do not choose answer choice A. Now let's talk about answer choice B. When we look at answer choice B, we have x cubed is less than x. I could subtract x from both sides and get x cubed is minus x is less than 0. That's going to let me factor out the left side. Now, I have a greatest common factor of x, and that would give me x squared minus 1 when I do that. But one of the nice things about this is x squared minus 1 also factors. Okay, that's a difference of squares, or a squared minus b squared equals a plus b times a minus b. So x squared minus 1 factors to be x plus 1, x minus 1. Now, I see three things here, and it's less than 0. And I'm like, oh gosh, that's a little rough for my trying to figure out what works. So what I'm going to do is I'm going to pretend like I have a number line, and I'm going to plot everywhere where it equals 0. So x equals 0 would cause this to be 0. -1 and +1 would also make it 0. Now, since it's less than 0, we can't actually include those values. All right, if it was less than or equal, you could. And then we're just going to test a few things. We're going to say, okay, if I plug in something less than -1, between -1 and 0, between 0 and 1, and more than 1, all right? I'm going to see what works. So for example, if I plug in -2 into this setup, do I get a negative number? Well, in fact, I do. So I can shade that part. -1 to 0 is maybe -1/2. When I plug that in, though, I get a positive. So I don't keep that part. Then between 0 and 1, I'm going to pick +1/2. So I have a positive, positive, negative. Well, positive times a positive is positive, but I multiply by a negative, I get a negative. So this does come out to negative. And then if I plug in something to the right of here, let's say 2, I get a positive, 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 which comes out positive. So no go. All right, so I have solutions here that are negatives. I also have solutions that are positives. Therefore, I have fulfilled the requirements of what the question asked me for. B is a valid answer. Now let's take a look at our last one here. Part C, x minus 6 is less than x minus 7. Is there at least one positive and one negative solution to that inequality? Well, let's see. I'm going to subtract x from both sides. When I do that, I get -6 is less than -7. Well, first of all, there are no x's left over, so not a good sign. And second of all, this is a false statement. So no, we cannot actually include C at all. Answer choice B is the only one for this problem.